Welcome to Basic Mathematics. Simple and basic algebra.
The content of this video, it is about Introduction to Algebra. Is algebra same as arithmetic? Algebraic expressions and its nomenclature, basic laws and rules for algebra, word problems to expressions and equations. We will also learn some simple and important identities, simultaneous linear equations, quadratic equations, and how to solve them and general solutions. Total of 40 examples are used to explain it. What is algebra? It is same as arithmetic, where some numbers are represented by letters, like 2 times 4 is equal to 8, or 2 times A equals 2A. Here 4 is replaced by A. To avoid confusion with other letters, sign of multiplication, times, is avoided in algebra. Algebra is one of the branch of mathematics in which arithmetic operations and other formal manipulations are applicable. Is algebra the art of making equations and formulas? To some extent, we can say yes. Algebra became an area of maths when in 16th century, mathematician François Viet used letters for variables or unknown numbers, which was done to represent numbers in mathematical formulas. Use of pi is one of the examples where Greek letter pi is used instead of 3.141592653589793. In algebra, shorthand is used not only to replace big numbers by a letter, but also for some of the arithmetic operations. A means in algebra 1 times or 1A. Minus A means -1 times or -1A. 5A means 5 times A or 5A. AB means A times B. 3AB means 3 times A times B or AB plus AB plus AB. Note: the number is kept in front of the letter, and all letters in variables are in alphabetic order. A by B or A over B means A divided by B or 1 by B of A. Note: symbols of division and multiplication are avoided in algebra. Brackets may be used to show multiplication. For example, x plus 3 and x minus 7 means x plus 3 times x minus 7. The constant and the variables. When letters are used to represent different numbers, they are called the variables. Letters which have fixed value are called the constant. For example, the area of the circle equals pi r squared, and circumference of the circle equals 2 pi times r. Value of the r, which represents the radius of a circle, will vary from circle to circle. Hence r is variable, but 2 and pi are constant, as pi equals 3.14159. The term and the constant terms. In any algebraic expression, each one is called the term. For example, in the expression 7x plus 4y minus 9, 7x, 4y and 9 are terms. Numbers on its own and letters standing for constant value are called the constant terms. In the expression of circumference of the circles P equals 2 pi r, 2 and pi are constant terms. In any algebraic expression, the number standing in front of a variable is called the coefficient. In algebraic expression 7x plus 4y minus 9, 7 is the coefficient of x, and 4 is the coefficient of y. The like term like terms means same algebraic letter is used in each terms. In any expression, like terms are x, 3x, minus 5x, or y, 4y, minus 6y. But x, y, are two different letters for two variables. The like terms are when the letters and the power of the letters are same. For example, for x squared, 7x squared are like terms. For x squared y and minus 3y, x squared are like terms. But for x squared y and y squared x are not the like terms. Notations for algebraic expression. As we learn, 7 types of names are given depending their roles, like 1. Term, 2. Coefficient, 3. Constant term, 4. Variables, 5. Constants, 6. Power, 7. Operator. In this case, 5x squared is a term and 3xy squared is also a term. If you look here, 5 and 3 are coefficient. C is constant. X squared or x and yx. Both x and y are variables. While 7 standalone number is also known as constant. In the first term, x squared, here the 2 is the power of the term. Mathematic operators plus and minus are used in the expression. Simplification of the expression. As in arithmetic, the expressions in algebra can be simplified using mathematical operators such as addition, subtraction, multiplications, division, powers of and roots of. Also we do substitution and forming and removing of brackets. Rules and laws of mathematics. Simplification by Bodmer's rule. As in arithmetic, the expressions in algebra with multiple operations need to be solved from left to right using Bodmer's rule, which tell us the order of application of mathematical operators. Bodmer's is acronym of B4 brackets x plus y minus z plus y. O4 order of power x cubed or x to the power of 3, and roots like fourth root of x. D4 divisions x divided by y, x or y. M4 multiplications x times y, x multiplied by y. Additions x plus y. Subtractions x minus y. A commutative law. Commutative law, in mathematics, states that the order of numbers can be swapped or changed around mathematical operations of addition and multiplication. 20 plus 4 equals and same as, for plus 20 is equal to 24. 32 times 4 is equal to and same as, for times 32 is equal to 96. Commutative law is applicable in algebra also. X plus y equals y plus x. X times y equals y times x. Or yx equals x of y. See more example of commutative law in this chart. Please note, commutative law is not applicable in the operation of subtractions and division. See chart. 2 minus 4 is not equals to 4 minus 2. So is A minus B is not equals to B minus A. Note, 2 divided by 4 is not equals to 4 divided by 2. So is A divided by B is not equals to B divided by A. Associative law. Associative law in mathematics states that while adding or multiplying, grouping of number does not change the results. Note here, 2 plus 4 plus 3 equals 6 plus 3 is equal to 9. Or 2 plus 4 plus 3 equals 2 plus 7 equals 9. For multiplication, 2 by 4 times 3 is equal to 8 times 3 is equal to 24. Or 2 times 4 by 3 is equal to 2 times 12 equals 24. See more example of associative law in this chart. Please note, associative law is not applicable for subtractions and divisions. See the chart for explanations. Distributive law. Distributive law in mathematics allows us to break down large, often complex sums into smaller ones. It states that multiplying a group of large 2 or 3-digit numbers will create the same value as those numbers being partitioned, multiplied and added together. 3 times 4 plus 5 equals 3 times 4 plus 3 times 5 is equal to 27. 3 times 45 equals 3 times 40 plus 3 times 5 is equal to 135. See more explanations of distributive law in this chart. Zero properties law. When multiplying by zero, result is always zero. In arithmetic, when 0 is multiplied by 210 or 210 is multiplied by 0, the result is always 0. 0 times 210 is equal to 0. In arithmetic, when dividing, when 0 is divided by 45, the result is 0. When 45 is divided by 0, the result is infinity. Same in algebra. When 0 is multiplied by variable y or the variable y is multiplied by 0, the result is always 0. When 0 is divided by variable y, the result is 0. When the variable y is divided by 0, the result is infinity. Zero properties law. For addition and subtraction, it tells us it makes no difference to the results if 0 is added or subtracted. See chart carefully.
Addition and subtraction. In algebraic expression, like terms are sorted out first.
then are simplified by mathematical operation. The expression for x plus 3y plus 2z plus 8 plus 3x plus 7y plus 3 plus 2z plus 4y plus 2z plus 5 times plus 7 plus z is sorted out for like terms and rewritten in order as for x plus 3x plus 5x plus 3y plus 7y plus 4y plus 2z plus 2z plus 2z plus z plus 8 plus 3 plus 7. Group them together and apply mathematical operations. Finally, we have simplified expression as 12x plus 14y plus 7z plus 18. Take special care when negatives minus symbol or numbers are in the expression. An example with subtraction or negative number. For times minus 3y plus 2z minus 8 minus 3 times plus 7y plus 3 plus 2z plus 4y minus 2z plus 5 times plus 7 minus z. The expression is sorted out for like terms and grouped together. Now proceed for simplification. Multiplication and removing brackets. Bracket are used to group terms together. An expression with bracket in it can be replaced by an equivalent one without bracket. To remove brackets, use the distribution law. Multiply the divide the term outside the bracket by each term inside the brackets. Example: for times x plus 3 equals for times x plus 4 by 3. Or the 2 plus y whole divided by x equals 2 divided by x plus y divided by x. Multiplication. After like terms are sorted out, the mathematical operation like multiplications are applied. Examples 1. 7 times 3x plus 7y. Open the bracket and multiply coefficients of each terms in bracket by 7. 7, 3x plus 7y equals 7 times 3x plus 7 times 7y equals 21x plus 49y. Examples 2. For x times bracket 3x plus 7y. Open the bracket and multiply each terms as for x times bracket 3x plus 7y equals for x times 3x plus for x times 7y equals for times 3 times xx plus for times 7 times xy equals 12x squared plus 28xy. Multiplication of two brackets. Multiplication is applied after sorting like terms. Take an example. For x minus 3y is multiplied by 3x plus 7y. For x minus 3y times 3x plus 7y. Open the first bracket. Equals for x times 3x plus 7y minus 3y times 3x plus 7y. Open the second bracket. Equals for x times 3x plus for x times 7y minus 3y times 3x minus 3y times 7y. Multiply each term. Equals 12x squared plus 28xy minus 9yx minus 21y squared. Arrange the like terms. Equals 12x squared plus 28 minus 9xy minus 21y squared. Equals 12x squared plus 19xy minus 21y squared. If we use tradition method for multiply, then like terms must be kept in the same place column. For examples, multiply for x 3y by 3x plus 7y. The term 9xy and 28xy are like term in 2 multiplication are kept one column and added together. Factors. In mathematics, a number or algebraic expression that divide another number or expression evenly have a factors. For example, number 12 has factors. 12 is equal to 1 times 12. 12 is equal to 1 times 2 times 6. 12 is equal to 1 times 2 times 2 times 3. 12 is equal to 1 times 3 times 4. So 1, 2, 3, 4, 6 and 12 are factors of 12. The number 16 has factors. 16 is equal to 1 times 16. 16 is equal to 1 times 2 times 8. 16 is equal to 1 times 4 times 4. So 1, 2, 4, 8 and 16 are factors of 16. In algebra, the factors mean the expression that divides another expression evenly, with no remainder. For example, 5xy. 5xy equals 1 times 5xy. 5xy equals 5 times xy. 5xy equals 5x times y. 5xy equals 5 times x times y. So 1, 5, x, and y are factors of 5xy. Remember, 1 and the number itself are always the factors of the number. In algebra, each term in an expression can be factorized. For example, in the expression 9xy squared minus 6yz, term 9xy squared equals 9 times x times y is equal to 3 times 3x times y has factors 1, 3, 9, x and y. Term 6yz equals 2 times 3 times y times z has factors 2, 3, y, z. Common factors. Identifying common factors, or highest common factors, in two or more integers. Help us to simplify the calculation. Please note, 1, 2, 3, 4, 6 and 12 are factors of 12, and 1, 2, 4, 8 and 16 are factors of 16. 1, 2 and 4 are common factors of 12 and 16. Knowing highest common factor, we can simplify the expressions. For example, 12 divided by 16. 12 divided by 16 equals 3 by 4 / 4 by 4 equals 3 divided by 4. In algebra, identifying common factors in two or more terms. Help us to simplify the expressions. Please note in 9xy² minus 6yz term, 9xy² equals 9 times x times y equals 3 times 3 times x times y has factors 1, 3, 9, x and y. And term 6yz is equal to 2 times 3 times y times z has factors 1, 2, 3, 6, y, z. 3 and y are common factors of both the terms in the expression 9xy² minus 6yz. So we can simplify the expression 9xy² minus 6yz as 3y times 3xy minus 2z. The substitution. In algebra, the substitution is replacing letter by numbers, and vice versa. This is used to find a numerical value for the expression. Example: if x equals 2 and y equals 6, find the value of 3x is equal to 3 times 2 equals 6. Find the value of x² is equal to 2 times 2 equals 4. Find the value of 3xy equals 3 times 2 times 6 is equal to 36. And of x plus 6y equals 2 plus 6 times 6 is equal to 38. Types of algebraic expressions. Types of algebraic expressions. A polynomial is a mathematics algebraic expression consisting of variables and coefficients that involve only the simple mathematic operation: addition, subtraction, multiplication and positive integer power of variable. An example of an algebraic expression with two variables x and y. 3x to the power of 3 plus x squared plus xy minus y squared. The algebraic expression can be classified generally as 1. Monomial, 2. Binomial, 3. Trinomial, 4. Polynomials multinomial. Monomial A monomial is an algebraic expression that has only one non-zero term. For example, 9x is a monomial in one variable x. 3x squared is a monomial in one variable x of second order. 5xy is a monomial in two variables x and y. 3xyz is a monomial in three variables x, y, and z. Binomial. A binomial is an algebraic expression that has two non-zero terms. For example, a plus 2b is a binomial in two variable a and b. 3x minus y squared is a binomial in two variables x and y of second order. 5x plus zy is a binomial in three variables x, y, and z. 3xy minus 5xyz is a binomial in three variables x, y, and z. Trinomial. A trinomial is an algebraic expression that has three non-zero terms. For example, a squared plus 2ab plus a is a trinomial in two variables a and b. 3x squared plus xy minus y squared is a trinomial in two variables x and y of second order. 5x minus y plus zy is a trinomial in three variables x, y, and z. 3xy plus yz minus 5xyz is a trinomial in three variables x, y, and z. Polynomial. A polynomial is an algebraic expression that has two or more than two non-zero terms. For example, a squared plus 2ab plus a is a polynomial in two variables a and b. 3x plus xy minus y plus y squared is a polynomial in two variables x and y. 5x plus zy minus xy plus z is a polynomial in three variables x, y, and z. 3x squared y plus for xz plus 6xy minus 5xyz is a polynomial in three variables x, y, and z. Index and law of indices. Index or indices. Use of index. Sometimes it is a simple way to express a number or expression using index form. For example, 3 to the power of 4, which means 3 times 3 times 3 times 3 is equal to 3 to the power of 4. Or x times x times x times x equals x to the power of 4. We read it as x to the power of 4. Here x is the base, and 4 is the index. Indices is plural of index. Note again. For example, y squared times y cubed equals y times y times y times y times y equals y to the power of 5, and x squared times y cubed times xy squared equals x times y times y times y times x times y equals x cubed times y to the power of 5. Note: for same base, the power is added on multiplication. Negative indices. Using index form. In division, indices in denominator are considered as negative indices when numerator is divided by denominator. For example, x squared divided by x equals x to the power of 2 minus 1 equals x. Or x squared times 1 divided by x equals x squared times x to the power of minus 1 equals x squared 2 times x to the power of minus 1 equals x to the power of 2 to 1 equals x. X to the power of 4 divided by x squared equals x to the power of 4 times x to the power of minus 2 equals x to the power of 4 minus 2 equals x squared. Net power 4 minus 2 is equal to 2. Note: when we divide, the power becomes negative. For same base, the power is added in negative numbers. Note again in next example. Laws of indices. Fundamental rules of indices are same in algebra as they are in arithmetic. In algebra, use of indices is more frequent. Rule number 1. If index is 0, then result is always 1. For example, 7 to the power of 0 is equal to 1. Z to the power of 0 is equal to 1. Rule number 2. If index is negative, then the result is the reciprocal of positive index. X to the power of minus 3 equals 1 x to the power of 3. Other example. 7 to the power of minus 2 equals 1 7 to the power of 2. Z to the power of minus 5 is equal to 1 divided by Z to the power of 5. Rule number 3. If two variables of same base are multiplied, then the power are added and raised them to same bases. x to the power of p times x to the power of q equals x to the power of to p plus q. Other example. 7 to the power of 2 by 7 to the power of 3 is equal to 7 to the power of to 5. Y to the power of 2 y to the power of 3 equals y to the power of 5. Rule number 4. When two variables of same base are divided, then the power of variables in denominator is subtracted from the power of variables in numerator and raise them to same bases. X to the power of p divided by x to the power of q equals x to the power of p divided by x to the power of q equals x to the power of p minus q. For example, 7 to the power of 5 divided by 7 to the power of 3 is equal to 7 to the power of 5 minus 2 is equal to 7 to the power of 3. Xto the power of 4 times y to the power of 6 divided by x to the power of 2 y to the power of 3 equals x squared times y cubed. Rule number 5. When a variables with their indexes raised again with another index, power, then the indices of same base are multiplied and raise them to same bases. X to the power of p to the power of q equals x to the power of pq. For example, 7 to the power of 5 to the power of 3 equals 7 to the power of 5 times 3 is equal to 7 to the power of 15. Y to the power of 2 to the power of 3 equals y to the power of 2 times 3 is equal to y to the power of 6. Rule number 6. When two variables of different bases, but of same index, are multiplied, then the same index is raised to the product of two bases. X to the power of m times y to the power of m equals xy to the power of m. Rule number 7. When two variables of different bases, but of same index, are divided, then the same index is raised to the division of two bases. X to the power of m divided by y to the power of m equals x divided by y to the power of m. Rule number 8. Fractional indices can be written as rational, as shown below. X to the power of 1/2 equals square root x. Y to the power of 2/3 equals cube root of y to the power of 2. Also note here x to the power of 7 divided by 4 equals 4th root of x to the power of 7. The algebraic identities. An algebraic identity is basically an equation in which left-hand side is equal to right-hand side of the equation for all values of the variables. To solve or to simplify some of the expressions, we can apply some of the easy-to-remember identities, such as x plus a multiplied by our x plus b equals x squared plus a x plus b x plus ab. We will show the proof of this identity. To prove, let's take left-hand side x plus a multiplied by x plus b equals x times x plus b plus a times x plus b after opening the first bracket. Left-hand side equals x times x plus b x plus a x plus a times b after opening the second bracket. Now equals x times x plus a x plus b x plus a times b, arranging the terms. So left-hand side equals x squared plus x plus bx plus ab, which is right-hand side. X squared minus y squared sad smiley x plus y multiplied by x minus y. To prove, take right-hand side x plus y into x minus y equals x times xy plus y times x minus y after opening the first bracket. Equals x times x minus x times y plus y x minus y times y after opening the second bracket. Hence x squared minus y squared sad smiley x plus y multiplied by x minus y. X plus y a whole squared equals x squared plus 2xy plus y squared. To prove, let's take left-hand side x plus y squared equals x plus y times x plus y equals x times x plus y times x plus y after opening the first bracket. Now equals x times x plus x times y plus y times x plus y times y after opening the second bracket. Left side equals x squared plus 2xy plus y squared 2, as xy equals yx, arrange the like terms. Left-hand side, x plus y whole squared equals x squared plus 2xy plus y squared equals right-hand side. X minus y whole squared equals x squared minus 2xy plus y squared. To prove, let's take left-hand side x minus y whole squared equals x minus y times x minus y equals x times x minus y times x minus y after opening the first bracket. Left side equals x times x minus x times y minus y times x plus y times y after opening the second bracket. Now equals x squared minus 2xy plus y squared, as xy equals yx, arrange the like terms. Left side, x minus y whole squared equals x squared minus 2xy plus y squared equals right hand side.
Forming expressions.
Forming expressions. Algebraic expression can be formed from the word statements. For example, John has 3 more books than Sonia has. So, if Sonia has n number of books, then John has n plus 3 number of books. So, 3 more than her means n plus 3. Or similarly, if 5 less than means n minus 5. Or, for times means 4 times n. Or, a quarter of means n divided by 4. Algebraic expression from the statements in words. Take another example. Sam has X number of more books than Maria has. So, if Maria has n number of books, then Sam has n plus X number of books. So, X more than the number means n plus X. Similarly, if y less than the number means n minus y, or x times the number means x times n, or the number divided by y means n divided by y. Use of flow diagrams. If any statement contains more than a couple of instructions, then the expression can be formed using a flow diagram in the same order as word statements are. To give you an example, take a quiz and follow the instruction. Number 1. Think of a number. Number 2. Multiply it by 3. Number 3. Subtract 7. Number 4. Now multiply the result by 5. And last, add the original number you thought of. Use of flow diagram. Follow the instructions as follows. Think of a number. Say x. Multiply it by 3. So it is 3x. Subtract 7. So it is 3 times x minus 7. Multiply the result by 5. It becomes 5 multiplied to 3 times x minus 7. Add the number you thought of. So the final expression is 5 multiplied to 3 times x minus 7 plus x. Word problem. Into an equation. Let us take an example. Jonas will be 3 times of his age in 6 years. How old is he now? We solve this problem using algebraic expression and equations. Let the current age of Jonas is x. After 6 years, the age of Jonas will be x plus 6. As mentioned above, we form the equation as after 6 years, the age of Jonas will be equals 3 times of x, or equals 3 times x. After 6 years, the age of Jonas x plus 6, which is same as 3 times x. Two expressions represent same thing and are equal. Equating them, we form an algebraic equation as x plus 6 equals 3 times x. Simplifying it, 6 is equal to 3 times x minus x, or 6 equals 2x. Implies x equals 3. The current age of Jonas is 3 years. Forming expressions, we now take another example. A boy buys x number of apples and y number of banana. Cost of one apple is p, and that of one banana is q. Now, write the expression for total cost of the fruit, say z. Cost of one apple is p. So the cost of x number of apples are p times x. Cost of one banana is q. So the cost of y number of bananas are q times y. Total cost z of apples and bananas is p times x plus q times y. What is the expression for the average cost of the fruits? Let the number of apple is x, and number of banana is y. Total numbers of apple and banana are n equals x plus y. Total cost z of apples and bananas is px plus qy. Average cost of the fruit, apples and bananas is v equals z divided by n equals p px plus qy divided by ax plus y. So the expression for average cost can be written as p times x plus q times y divided by x plus y. Equations mean when two expressions of two statements are same. It can be represented by the sign of equals to equals, or left-hand side equals right-hand side. Word problem into an expression. Take an example. Sam's age is 3 times that of Yona's. 1 year back, Sam's age was 4 times of Yona's age. How old are Sam and Yona's now? We solve this problem using algebraic expression. Note, this time we have 2 unknown variables and 2 conditions to form the equations. Let the current age of Yona's is x. Let the current age of Sam is y. From first condition, Sam's age is 3 times of Yona's age. It means y equals 3x. This is the equation number 1. It is a linear equation with 2 variables, x and y. One year back, the age of Yona's 3 was x minus 1. 1 year back, the age of Sam was y minus 1. From second condition, 1 year back. Sam was 4 times of Yona's age. It means y minus 1 equals 4 times x minus 1. This is the equation number 2. This is another linear equation with 2 variables, x and y. We solve 2 unknown variables, x and y, from 2 equations. To solve, we take y equals 3 times x from equation number 1 and put this value of y in equation number 2. That is, y minus 1 equals 4 times x minus 1. Therefore, 3x minus 1 equals 4 times x minus 1. This is the equation number 3. with one variable x. Further we solve the equation number 3. 3x minus 1 is equal to 4x minus 4. Or, for minus 1 is equal to 4 times x minus 3 times x. Therefore x equals 3. From eq.hash1. Since y equals 3 times x putting the value of x, therefore y equals 3 times 3 equals 9. The current age of Jonas is 3. And that of Sam is 9. Example 6. Sum of three unknowns numbers is 12. Sum of first two numbers is 2 more than the third number. The sum of last two numbers is 3 times the first number. Let the numbers are x, y and z. The sum of three number is x plus y plus z equals 12, is equation number 1. The sum of first two number x plus y is 2 more than z. X plus y equals z plus 2, or x plus y minus z equals 2, is equation number 2. The sum of last two number y plus z is 3 times x. Y plus z equals 3x, or 3x minus y minus z equals 0, is equation number 3. Note, all three are linear equation with 3 variables. To solve these equations, to determine all unknown variable, we take 2 equations at one time and try to eliminate one variable. Step 1. Take equations number 1 and number 2 and subtract out equation number 2 from equation number 1. Equation number 1 is x plus y plus z equals 12. Minus equal number 2 is minus x minus y plus z equals minus 2, or 2z equals 10, or z equals 5, is equation number 4. Step 2. Note z equals 5 in the equations number for now replace z in equation number 1 and equation number 3. Equation number 1 is x plus y plus z equals 12. So x plus y plus 5 equals 12, x plus y equals 7, is equation number 5. And equation number 3 is 3x minus y minus z equals 0. Or 3x minus y minus 5 is equal to 0. Or 3x minus y equals 5 is equation number 6. Step 3. Take equations number 5 x plus y equals 7 and add equation .#6 3x minus y equals 5 for x equals 12 is equation number 7. Step 4. Take equations number 7 x equals 3 and replace x in equation number 5. X plus y equals 7. The equation number 5 is x plus y equals 7. Or on replacing x equals 3, 3 plus y equals 7. or y equals 7 minus 3 is equal to 4. Finally, x equals 3, y equals 4 and z equals 5. Word problem. Into expressions. Example 7. The age of Sonia's mother is the square of her age. The age of Sonia's father is 6 times of her age. Sonia's father is 5 years older than her mother. How old are Sonia and her parents? Let the age of Sonia is X. Let the age of Sonia's mother is Y. Let the age of Sonia's father is Z. Condition number 1. The age of Sonia's mother is the square of her age. So the first equation is y equals x to the power 2. This is equation number 1. Condition number 2. The age of Sonia's father is the 6 times of her age. So the second equation is z equals 6x. This is equation number 2. Condition number 3. Sonia's father is 5 years older than her mother. So the third equation is z minus y equals 5. This is equation number 3. We have to find out 3 unknown variables from 3 equations, as equation number 1 and number 2 have only 2 variables. We can find the value of one variable in terms of another variable. From equation number 1, we have the value of y in terms of variable x. Equation number 1, y equals x squared. From equation number 2, we have the value of z in terms of variable x. Equal number 2, z equals 6x. So we put these values of y and z in the equation number 3. Z minus y equals 5. In the equation number 3, z minus y equals 5, or x squared minus 6x plus 5 equals 0. This is a quadratic equation. How to solve such equation will be taken later. Or x squared minus 5x minus x plus 5 equals 0. X times x minus 5 minus x minus 5 equals 0. X minus 5 times x minus 1 equals 0. So, the solution is either x minus 1 equals 0, therefore x equals 1, or x minus 5 equals 0, therefore x equals 5. On testing first solution, x equals 1, y equals x squared, therefore y equals 1. This is not the right solution, as it gives same age for Sonia and her mother. Go for second solution. X equals 5. Y equals x squared. Therefore y equals 25. This is reasonably right solution, as age of Sonia is 5, and her mother is 25, and her father's age is z equals 6x equals 6 by 5 equals 30. So, Sonia is 5 years. Her mother is 25 years and her father is 30 years old.
Thank you. This video will continue in its next part.